Hello everyone, today we will continue our discussion from the previous class, which is about logic, predicate logic and quantifiers. So we have said something about propositional logics in the previous class. So the predicate logic is an extension of propositional logic that promises concisely the reasoning about whole classes of entities. So propositional logic ይቀጥላል concept ነው ይሄ, which is predicate logic እንለዋለን. So when you can take this one as an example, x is greater than 1 and x plus y is equal to 10. You can see that these two sentences are not true or false unless and otherwise the variables are substituted by some numbers, which is taken from the set of universe or the universe of discourse. So the collection of all values of x and y's that the variables are taken is called universe of discourse. የተሰጠንን statement or preposition true or false ለማለት variableዎቹን substitute የምናደርግበት set is called set of discourse or universal set እንለዋለን። For instance, in this example, let p of x is equal to x plus 1 greater than x here. So p of x is an open proposition now. So we could find the course of the universe or universal discourse or the universal set as a set of integers. So set of integers in the universe of discourse argan ziga x variable ላይ የተካንስነድ we can say that this statement is true or this statement is false ብለን substitute እናደርጋለን ማለት ነው። So ይሄ ነው predicate logic የሚለው እዚህ ጋር ነው የሚያጠናው ማለት ነው። predicate logic የሚለው ይሄን እነዚህ ነገሮች ያጠቃልላል። It depends on the open preposition. What's an open preposition now? So clearly an open preposition, also called a predicate, is a sentence that contains one or more variables and whose truth values depends on the values assigned for the variables, where the variables are come from the course of the universe discourse or the set of universal set. Universal set የምንወስዳቸው variables ሆነው open preposition ወይም ደግሞ predicate የሚለው sentence one or more than one variable contain ሊያደርግ ይችላል። truth value ግን depend የሚያደርገው substitute በምናደርግባቸው x እና y variables ነው ማለት ነው። where x እና y variables ደግሞ ከset of discourse ይሰጣል፣ universal set ይሰጣል ማለት ነው። ከዛ የምንወስዳቸው values ናቸው ማለት ነው። So this is what an open preposition means. So we represent mostly an open preposition by using capital letters followed by variables and which are in parentheses, just like these ones. P of x, q of x, r of x, y, etc. Let's take this example. Here are some open prepositions. X is the day next to Sunday, and y is the city in Ethiopia. So clearly you can see that each of them are not prepositions. They are not prepositions, but they are open prepositions. So, and we cannot able to give the truth value for these statements, which means that unless and otherwise we substitute the values of x from the universal set or the course of universe, these statements are not prepositions. They are open prepositions. They are open prepositions. X ቦታ ላይ ወይም ደግሞ y ቦታ ላይ ከዩኒቨርሳል ሴት ወስደን substitute ስናደርግ ነው truth value የምናገኘው ማለት ነው። So which is called, ስለዚህ ምንድናቸው ማለት ነው? open preposition ናቸው ማለት ነው። They are called open preposition እንላቸዋለን ማለት ነው። As a remark, as we have said it before, the collection of all allowable values of the variables in an open statement. An open statement sentence is called the universal set or universal discourse, and it's denoted by the U capital U. So two open prepositions are said to be equivalent, P of x and Q of x are said to be equivalent if and only if P of A is equal to Q of A for all individual A that are taken from the universal set or the universe of the discourse. So ሁለት open prepositions እኩል ናቸው የምንለው truth valueቸው ለእያንዳንዱ ኤሌመንት ዩኒቨርስ ኦፍ ዲስኮርስ ውስጥ ያሉት ሁሉም ኤሌመንቶች ፒ እና ኪው ስቴትመንት ላይ ስናስገባቸው ሴንቴንሶች ላይ ስናስገባቸው truth valueቸው እኩል የሚሆንልን ከሆነ then we call it the two open prepositions are equivalent. Note that for universe U is specified, then P of x and Q of x are equivalent if P of A is equal to Q of A. For example, let's take these two open propositions. P of x is equal to x squared minus 1 is equal to 0, and Q of x is equal to x absolute value of x, which is greater than or equal to 1, where it's given the universe of discourse is given, U is equal to minus 1 over 2, 0, and 1. Now, let's substitute the values of these numbers on the on the open preposition P of x and Q of x. እናስገባቸው እስኪ ስናስገባ ምንድን ነው የሚሰጠን? P of minus 1 ስናስገባ which gives 0, which is a true statement, exactly. Minus 1 and the P of x plus sinaskaba 1 square and 1 minus 1, which is 0, which is true. Is that not? And Q of 1 minus 1 sinaskaba absolute value of minus 1 is 1, which is greater than or equal to 0, which is also true. P of minus 1 over 2 sinaskaba P of x, which is 1 over 4 minus 1, then 1 over 4 minus 1 is, which is minus 3 over 4, which is different from 0, which is a false statement. And Q of minus 1 over 2 is absolute value of minus 1 over 2 is 1 over 2, so which is greater than, which is not greater than equal to 1, which is also false. P of 0, which is equal to minus 1, which is different from 0 clearly, which is also a false statement. So Q of 0, which is equal to 0, so which is different from 1, or which is not greater than equal to 1, so that it's also false. The last one, P of 1, which is 0, and it gives 0, which is a true statement. And Q of 1, and absolute value of 1 is 1, which is greater than equal to 1, which is true. So clearly you can see that the truth values of each individual in the universal set gives the same truth value. True, P of minus 1 is true, Q of minus 1 is true, P of minus 1 over 2 is false, Q of minus 1 over 2 is false, and P of 0 is minus 1, which is false, and Q of 0, which is also false. P of 1 is true, and this one is true. So clearly you can see that the truth values of the two open prepositions, when we are substituting individuals from the universal set, they give the same truth value. ስለዚህ ሁለቱ open prepositions ምን ናቸው ማለት ነው? ኢኩቫለንት ናቸው ማለት ነው። regardless of the value they give ማለት ነው። አሁን P of minus 1 0 ነው የሰጠን፣ Q of minus 1 ደግሞ 1 ነው የሰጠን። 0 እና 1 ይለያያሉ። ነገር ግን እኛ የምናየው truth valueያቸውን ነው እንጂ የሚሰጡንን value አይደለም። P of minus 1 is equal to 0 ሲሰጠን truth value እዚህ ጋር ቢሰጠን preposition ላይ true ነው false ነው የሚለውን truth value ነው እንጂ we do not consider the value that the open preposition has gives. So እዚህ ጋር የምናየው ቫልዩዎችን አይደለም። እነዚህ ማይነስ ለምሳሌ እዚህ ጋር የሰጠኝ 3 over 4 minus 3 over 4 ነው። እዚህ ጋር ደግሞ ያገኘሁት 1 over 2 ነው እንደምታዩት። ስለዚህ ሁለቱ ይለያያሉ። ነገር ግን ትሩዝ ቫልዩአቸው ግን ምንድነው? ተመሳሳይ ነው። false ነው። ስለዚህ የምናየው ትሩዝ ቫልዩ ነው ማለት ነው። So if the truth values of two open prepositions gives the same truth value, then the two prepositions are said to be equivalent. So the other one is quantifiers, another way to make a predicate into a preposition or open preposition or a preposition. We can use quantifiers. So quantifiers allow us to quantify or count how many objects in the universe of discourse satisfy the given predicate. ምን ያህሎቹ ሳቲስፋይ ያደርጉታል የሚለውን ኳንቲፋየሮቹ ኳንቲፋይ ያደርጉልናል ማለት ነው። So quantifiers are very important in identifying the given open preposition is true or false. So a predicate is true or false for all possible values of the universe of discourse or some values of the universe of discourse. ለሁሉም ፕሬዲኬቶች ኳንቲፋየሮቹ ለሁሉም ትሩዝ ቫሉስ ትሩ መሆናቸውን ወይም ደግሞ ፎልስ መሆናቸውን እናያለን ማለት ነው። የምናይበት ነው ማለት ነው። ይሄ ኳንቲፋየሮችን ይዘን ለሁሉም possible values of the elements in the universe of discourse satisfy ማድረጋቸውንና ወይም ደግሞ ለተወሰነ ኢንዲቪጁዋል satisfy ማድረጋቸውን ቼክ እናደርጋበታለን። So there are two quantifiers, the universal quantifier and the existential quantifier. So let's see the universal quantifier first. So the phrase for every x is called the universal quantifier. This phrase is called the universal quantifier, and for every x has the same meaning with for all x or for each individual x, and it's symbolized by this one. The inverse is a capital A, the inverse is a capital A. All for all x, you can represent using this one. So if p of x is an open preposition with inverse and set u, then for this one, for all x, p of x is quantified preposition and is read as for every x or for each x an element in the universe of discourse has a property p. ስናነበው ለእያንዳንዱ የx value from the universe of discourse satisfy ያደርግልናል ማለት ነው። property p satisfy ያደርግልናል እንደማለት ነው ስናነበው። ሌላኛው existential quantifier የምንለው ማለት ነው። The phrase there exists an x is called an existential quantifier. So there exists an x for some x for at least one x has as having the same meaning with there exists an x. For at least one x for some x there exists an x have the same meaning, and we represent the existential quantifier by this one. There exists x. It's this one. If p of x is an open preposition with the universe of discourse, then when we read this one, we can say that there exists x or for some x in the universe of x, the universe of discourse with the property p, satisfying the property p. There are some x's that satisfy the property p in the universe of discourse in the mind. Now, እነዚህን ኳንቲፋየሮችን ከተጠቅመን እንዴት ነው ፕሩፍ የምናደርገው? ትሩ መሆናቸው ፎልስ መሆናቸው ፕሪፖዚሽኖችን ኳንቲፋየር ከተጠቀምን በኋላ for all x for there exists x የሚሉትን ነገሮች ኳንቲፋየር ስናስገባ ኦፕን ፕሪፖዚሽን ላይ እንዴት አድርገን ነው ትሩ ፎልስ መሆናቸው ቼክ የምናደርገው? So we can use this remark to show that for all x p of x is false. It's sufficient to find at least one a in the universe of discourse such that p of a is false. Such a statement is said to be counterexample. ስለዚህ for all x p of x የሚለውን false መሆኑን ለማሳየት አንድ ካውንተር ኤግዛምፕል from the universe of discourse ወስደን ቼክ እናደርጋለን ማለት ነው። ያቺ አንድ ካውንተር ኤግዛምፕል ፎልስ የምታደርገው ከሆነ ስቴትመንቱ የተሰጠን ኦፕን ፕሪፖዚሽን then that preposition is false እንላለን ማለት ነው። for what? for all x የሚለው false ይሆናል ማለት ነው። for all x የሚለው አይሰራም ማለት ነው። false መሆኑን ቼክ እናደርጋለን ማለት ነው። ስለዚህ አንድ ኤግዛምፕል ነው የምንፈልገው ማለት ነው ፎልስ ለማድረግ for all x p of x ለምን ለሁሉ x የሚሰራ ከሆነ እኛ ለምንወስዳት ካውንተር ኤግዛምፕል x መስራት ነበረበት። so false መሆኑን ትሩ መሆኑን ቼክ ለማድረግ ኢንዳይሬክትሊ false የምታደርግልን አንድ ቫሪያብል አንድ ኤሌመንት in the universe of discourse እንወስዳለን ማለት ነው። similarly there exists x p of x is false መሆኑን if we cannot find any an element in the universe of discourse having the property p ማለት ነው። አሁን there exists x p of x የሚለው false ለማድረግ አንድ ኤሌመንት ማናገኝ ከሆነ we can say it false። ስለዚህ there exists x p of x አንድ ኤሌመንት በቂ ነው ትሩ ለማድረግ ይሄን ስቴትመንት ይሄን open preposition with a quantifier ይሄን preposition open preposition satisfy ለማድረግ እና true ለማድረግ አንድ ኤግዛምፕል በቂ ነው። but if we cannot find that one example ያንን አንድ ኤግዛምፕል ማግኘት ካልቻልን ግን we make it a false statement false እናደርገዋለን ማለት ነው። This is how to check the truth or falseness of the given open preposition using quantifiers. Let's see the relationship between existential and universal quantifiers. If P of X is a formula in X, consider the following 4 statements with their translate into the word as follows. Now, for all X P of X, when we're translating this one, for everything has a property P. ማለት ነው እያንዳንዱ for all X P of X, everything has a property P ማለት ነው there exists X P of X ማለት something has a property P. For all X, negation of P of X means that nothing has a property P እንደማለት ነው. And there exists X, negation of P of X is something does not have a property P እንደማለት ነው. Something does not have a property P. And clearly you can see that from these 4 words or expressions, the negating quantifiers are here. The negation of all for all X P of X is there exists X negation of P of X. Well, so when we are negating the universal quantifier, when we are negating this universal quantifier, it becomes the existential quantifier, and the negation of P, we apply negation on the open proposition. And when we are negating the existential quantifier, we will get the universal quantifier. It becomes a universal quantifier, and then the negation of the open proposition. So these 2 are the negation of the quantifiers, prepositions, open prepositions, quantifiers. So you can see that the negation for all X P of X is the fourth one, there exists X negation of P of X, and the negation of there exists X P of X is this one for all X negation of P of X. So this is symbolize the following quantifiers using quantifiers. Let's symbolize the following expressions using quantifiers. All rationals are reals. No rationals are reals. Some rationals are reals. Some rationals are not reals. So clearly, let's represent R of X is real numbers, and let's express Q of X as rational numbers. So the first one is all rationals are reals, which means that for all X, every X, Q of X implies R of X. So እያንዳንዱ rational real ነው። ስለዚህ ሁሉም rational number real number ነው ማለት Q of X implies R of X ነው። No rationals are reals. አሁን no rationals are reals ማለት ደግሞ እያንዳንዱ rational ሆኖ real ይሆን የለም ማለት no rationals are reals. rational ሆኖ real ያልሆነ የለም. So which means that all for all X, Q of X implies negation of R of X. rational ሆኖ real ያልሆነ no rationals are reals. And there exists X and some rationals are reals, which means there exists X, Q of X and R of X. Some rationals which real ናቸው. So which is connected by and some rationals are not reals. There exists X, Q of X and negation of R. Some rationals are reals. So clearly የተወሰኑ rationals ምን አይደሉ ማለት ነው real አይደሉ ነው express እናደርገው there exists X, Q of X and negation of R of X ይሆናል. So clearly D is the negation of A, the negation of A is D, and the negation of B is the negation of C is B. The negation of C is B. The negation of C is B. Now let's prove እንዴት ነው እንደዚህ ሆኖት ከዚህኛው ወደዚህኛው እንዴት ሙቭ ያደርጋል? Proof for all X, Q of X implies R of X. Given this one, then the negation of this statement, this statement, negation of all X, Q of X implies R of X. So the negation of all X is there exists X, and the negation of Q of X implies R of X. So there exists X by applying negation, by applying the equivalence rule of prepositions. Q implies R is the same as negation of Q or R. So it becomes the negation of Q of X or R. So applying negation on this one, you will get there exists X, Q of X, and by applying negation, when this one connected or will be changed into end. So Q of X and negation of R of X, which is D. So the negation of for all X, this one, and the negation of Q of X for all X, Q of X implies negation of R of X, which is just the negation for all X, Q of X implies negation of R of X. So the negation of for all X is there exists X, and the negation of Q of X implies negation of R of X. So implies the negation of r, the negation of q of x implies r of x, negating this one, negation of r of x, which is by applying equivalence rule. By applying the equivalence rule, negation of q of x implies negation of r of x is the same as negation of q of x or negation of r of x. So negation, you can take these two as common. This one is negation, this one is negation. So taking as common negation of q of x and r of x. So when we are taking negation as common, the connective or will be changed to and. So double negation of negation will be cancelled so that there exists x, q of x and r of x ማለት ነው። አያችሁት እዚህ ጋር negation ደብሉን ስናስወጣው የጋራ negation ይሰጠናል። ስለዚህ q of x and r of x. So clearly እዛ ጋር ያለው ማለት ነው። So example, there exists x, q of x and r of x. There are some rationals are reals ያለው some rationals are reals ያለው some rationals are reals የማን ኦፖዚት ነው? no rationals are reals የሚለው some rationals are reals የሚለው የማን ኦፖዚት ነው? no rationals are reals, the negation of no rationals are reals የሚለው እንደገና ደግሞ all rationals are reals የሚለው ደግሞ የማን negation ነው? some rationals are not reals. Some rationals are not reals is the negation of all rationals are reals. So this is how to prove these negations. Translate the following one. Negation of all x, x is mortal. So not everyone is mortal, or someone is not mortal. Someone is not mortal. Someone is not mortal. Someone is not mortal. ማለት እንችላለን ማለት ነው። and this one being ደግሞ for all x, negation of x is mortal. Negation of x is mortal. So everyone is not mortal. Everyone is not mortal. You can say everyone is not mortal. Or where is it? So negation of there exists x, x is mortal. No, there exists x, negation of there exists x, x is mortal. No, someone is mortal, you know, negates scenario, everyone is not mortal, everyone is not mortal. So the next one is determine the truth value of the following statements. For all x, x an element of real number, x squared minus x is equal to 0. For all x, you can see that to prove that this statement is true, false, we should find an example, counter example, says that x squared minus x is equal to 0, is not equal to 0. For instance, 1 over 2, let's take 1 over 2. 1 over 2 the whole square is what? 1 over 2 the whole square is what? 1 over 4 minus 1 over 2 is how much? 1 over 2, which is equal to what? Which is equal to 1 over 2, which is equal to 1 over 2, which is different from 0. Therefore, it's, we obtain one counter example to prove that this statement is false. This statement is false. There exists x, an element of natural number, x plus 1 is greater than or equal to 2. There exists x, an element of the set of natural number, x plus 1 is greater than or equal to 2. So we can find one example which satisfies this one. So it's true. For all x, an element of natural number, such that the square root of x squared, the square root of x squared is equal to x. The square root of x squared is equal to x. So is it true for every x? So let's say, to say this one is true, to say this one is false, let's find one counter example. And the counter example is false. The square root of x squared is different from x man. And the counter example is 0 minus 0 minus 0 is 0. 1 minus 1 is this one. So since set of universal setaችን ወይም set of universe of discourse natural numbers ስለሆነ ይሄ ነገር ለሁሉም ይሰራ ማለት ነው። So it's true ማለት ነው። It's true ማለት ነው። ይሄኛው true ብለናል። This one is also, this one is false ብለናል። አንድ counter example አግኝተናል። አሁን ይሄንን ኢንቲጀር ባደረገው set of integer ባደረገው ዩኒቨርሳል ሴታችን ምን ይሆናል ማለት ነው? set of integer ባደረገው ይሄንን ስቴትመንት ፎልስ የሚያደርጉልን ኤግዛምፕሎች መውሰድ እንችላለን። ለምሳሌ -1 ብወስድ the square root of -1 the whole square is 1, but this one is -1. So -1 is 1 is different from -1 one is different from minus one, it's false statement. So universe of discourse true false ለማለት አንድ የተሰጠ open proposition with quantifier true false ለማለት universe of discourse በጣም ወሳኝ ነው ማለት ነው. So this is how to find the truth value for the given examples. Quantifiers occurring in combination. The following are the simplest form of combinations of universal and existential quantifiers that give a new logical structure. For all x, for all I, p of x, y. See number z. For all x and for all I, p of x, y holds true ማለት ነው. For all x and for all y, p of x, y holds true ማለት ነው. ለዚህ ሁሉም x ሁሉና ሁሉም y የተሰጠ open proposition ይሰራል ማለት ነው. There exists x, there exists y, p of x, y. There is an x and there is a y for p of x, y holds true. To be p of x, y proposition to be true ለመሆን and x and y አግኝተናል ማለት ነው. To say this one is true. And for all x and there exists y, p of x, y. For every x there is a y such that p of x, y holds true. ለሁሉም y for all every x for all x there exists y ለሁሉም x value we can find corresponding y value such that p of x, y holds true. ለእያንዳንዱ x የምናገኘው value corresponding y ማግኘት እንችላለን. It's so that the p of x, y holds true ማለት ነው. And the last one there exists x for all y, p of x, y. There exists a unique x that stands for every y ማለት ነው. አንድ single x ለእያንዳንዱ y value satisfy ልታደርግልን የምትችል እናገኛለን እንደማለት ነው. There exists a unique x that satisfies p of x, y for every y in the universe of discourse level. So this is the combination of C2 in Muslim. To determine the value of the following statements. Truth value. There exists x element of real number and there exists y element of real number such that x plus y plus 3 is equal to 8. ስለዚህ there exists x, there exists y number. ስለዚህ አንድ ካገኘን ራሱ በቂ ነው ማለት ነው። ስለዚህ ሶስት እዚህ ጋር ተሰጥቶናል። አንድ እዚህ x አንድ ማድረጋት y ስንት ይሆናል ማለት ነው? x 1 ማድረግ y ስንት ይሆናል ማለት ነው? y is equal to 4 ይሆናል ማለት ነው። So it's one example, counter example to make this one true. For all x element of real number, there exists y element of real number x plus y is equal to 8. ለእያንዳንዱ x can we find corresponding y says that this statement is true? Clearly, we can find y is equal to, from the statement, we can take from the equation 8 minus x, which is 8 minus x. So you can take any value of x from the set of real numbers. So 8 minus x becomes y. So this statement is true first. This statement is also true. True statement. Legend x, we can find corresponding y says that this statement is true. There exists a single x for all y, which stands for all y, says that x squared plus y squared is equal to 25. Is that possible to find x squared plus y squared, a fixed x that satisfies this statement? Let me say x is equal to 5 post, x is equal to 5 post, the y is equal to 5. Y is equal to 5 5 was the because x squared, which is so x is equal to 5 post and y is equal to 5 post. He satisfied a unique x. When demo x and 5 post, y square is equal to the square root of x and 5 post, y is equal to x and let's change x and source y square is equal to 25 minus 9 y square is equal to y is equal to the square root of 25 minus 9. So ስለዚህ ይሄ 25 minus 9 y ሆነ ማለት ነው። ለሌሎቹስ ይሰራል ወይ ነው? ለእቺኛው አንዷ x ቫልዩ የy ለሌላው የy ቫልዩ ነበር አይሰራም። ስለዚህ ፎልስ ነው ማለት ነው። which is a false statement። እንደዚህ ነው ትሩዝ ቫልዩ ማግኘት እንችላለን ኢን ኮምቢኔሽን ሲመጡ ይሄንን ነው ማለት ነው። ሶ